Okay, ladies and gentlemen, I haven't done this in a little while, but let's go ahead and take a look at this. We did an example with a tape measure. We reeled the tape measure in, we had a distance, we had a time, and we wanted to find linear velocity, angular velocity, and RPM. So let's go ahead and walk through that particular example. Let's take a look, and let's assume that we have something that is a distance of approximately 47 feet. At 47 feet, let's assume a time of 3.9 seconds. What we want to do is we want to use that information using the tape measure that we had, which had a radius for the spool of 2 inches. And we want to find linear velocity. We want to find angular velocity. And we want to find RPM. Now, linear velocity, our most common formula is V equals omega R. Now we have a couple other formulas that we could go with, but you'll notice over here we have distance, we have time, we have R. We do not have omega. Now we could also use something like for angular velocity, omega equals theta over t, but I don't have a theta here either. Okay, so what we're going to do is we actually are going to want to start with linear velocity, because linear velocity is nothing more than a distance over a time. So V equals distance over time, and our particular distance is 47 divided by 3.9. Now, you'll notice I'm writing this vertically. The reason I'm writing it vertically is because we need to use dimensional analysis, or we need to use our units, whatever you want to call it. It's going to require us to not write things sideways, but to write things vertically so that we can clearly see it. Now, feet per second is not something we want, because eventually we want to get to RPM. At RPM, that means we need minutes. So let's just go ahead and get to those right now. How do I get rid of seconds? Well, I'm going to multiply by some conversion unit. And that conversion unit, I want seconds to be gone at some point. So I need seconds up here. That's going to be 60 seconds equals 1 minute. So here, those go away. Answer becomes 47 times 60 equals divided by 3.9. And by putting those together, I come up with 723 feet per minute. Now, that's linear velocity because it's a linear distance over a particular time. So, with that in mind, now I can use this formula right up here to find omega. So I want omega equals, well, let's see here. If I want to get omega by itself, it's nothing more than a little algebra divided by R. V over R. Now, our V is 723, and that is feet per minute. Now, we're going to divide that by R, our radius. Now, of course, I can't have one dimension in feet and the other dimension in inches, so we're going to say 1/6 of a foot. Ladies and gentlemen, fractions are not the enemy. Use them. So all we have to do is say 723 divided by, now I'm going to put 1/6 in parentheses, and I come up with 4338, and that's now, you'll notice the feet have canceled out because we're no longer in this straight line area. We're actually talking about something that's moving in a circle, and so that's going to be radians per minute. Now, with radians per minute, that's easy enough to move to RPMs. Now, RPM is really revolutions per, not minute, minute. And so we need to take our radians per minute, 4338, and that's in radians on top, over 1 minute in the bottom. So I have the unit of time that I want. What I don't have is I don't have my revolutions. So one revolution is 2 pi. So I'm going to take one revolution, going to divide it by 2 pi radians. Radians gone, and I'm left with 4338 all over 2 pi, which happens to be, so let's divide 4338 divide by 6.28, and that comes up with 690.76, and that is now in revs per minute. Okay, so nothing overly challenging about this. You have to look at your units. You have to write them out. You have to show your work. Ladies and gentlemen, this is not something you can just look at and have an answer for. We'll be back later with another video.